Hello, welcome back to another episode of Math with Haas. You are watching Precalculus Season 2, Episode 12. We're continuing our investigation of trigonometry. So, the first thing I want to do is recall our properties about our 6 trig functions, about the positive and negative. So, we talked about our quadrants before. Quadrants 1, 2, 3, and 4. And with our quadrants, we know that in quadrant 1, x and y are positive. Quadrant 2, we know we'll have a negative x and positive y. Quadrant 3, we have negative x, negative y values. And in quadrant 4, x is positive, y is negative. So we can make a table. So let's get our table going. So let's see here. Let's go trig function. Actually, no. We want to do quadrant, positive, and negative. So in quadrant 1, x and y are both positive. So what this means then, since x and y are both positive, then if we recall, sine of theta is equal to y, cosine theta is equal to x. Again, remember we are using the unit circle, so the radius is 1. Since sine and cosine are positive because x and y are positive, the other 4 trig functions were defined in terms of sine and cosine through the reciprocal identities. So, if we recall, I guess we need to move over here a little bit. Tangent theta was equal to sine theta over cosine theta. Cotangent theta is equal to cosine theta over sine theta. Cosecant theta is equal to 1 over sine theta, and secant theta is equal to 1 over cosine theta. There's our reciprocal identities, most of them. Now, when we think back to x and y here, since all 4 of the other trig functions are defined in terms of sine and cosine, since sine and cosine are both positive, that means all 6 trig functions are positive in quadrant 1, and none of them are negative. Quadrant 2, on the other hand, cosine is going to be negative because x is negative, whereas sine is positive. So when we look over here, we see, well, since sine, that's y is positive, sine's positive, cosecant's going to be positive. So sine, cosine, oh no, delete, cosecant theta. This is quadrant 2. Now we noted that since x is negative, that means cosine and secant. Now when we think about tangent and cotangent, they are sine divided by cosine, cosine divided by sine. In both cases, one of our trig functions is positive, the other one's negative. Positive number divided by a negative number, or negative divided by positive, is still a negative number. So that means we have tangent theta and cotangent theta hanging out in the negative column. And while I'm thinking about it, let's go ahead and add some columns and rows. That's looking better. Alright, quadrant 3. Sine and cosine are both going to be negative in this case because sine and x and y here are both negative. So that means sine theta, cosine theta, and secant and cosecant are all negative. On the other hand, since sine and cosine are both negative, tangent and cotangent are going to be positive because you have a negative number divided by a negative number. So tangent and cotangent are going to go over here. Alright, and let's extend this down. We got one more quadrant, quadrant 4. So let's look over here. Quadrant 4 says x is positive, y is negative. Well, x is positive, that's cosine. Y is negative, that is sine. And it also means secant's hanging out in positive land, and cosecant is hanging out in negative land. And again, since one is positive, the other is negative, and with reference to sine and cosine, since one's positive, one's negative, that means tangent and cotangent are hanging out here as well in negative land. Alright, so that concludes our table with our 4 quadrants. So we can see how quadrant 1, all are positive, none are negative, and then in the remaining 3 quadrants, it's either sine, cosecant, tangent, cotangent, or cosine and secant. Alright. Now, there's another set of properties that we are interested in. So I guess we'd call these the positive negative properties. So I guess let's put a title, positive / negative properties. And another set of properties we're interested in is called the even odd properties. So I'm going to leave this here for a moment so you can have that for reference if you need to write that down. Pause. Alright, now it is time to consider even odd properties. So there's our terribly deformed circle. XY axis is similarly deformed. We won't judge our circle here. And we better fix that. So we're going to make sure we go straight down. So here's x comma negative positive y, positive y, x comma negative y. Alright. So then we can draw our line from the center of the circle here. We're pretending that this is the same radius. It's a poor circle. So if we move from the positive x-axis on up, we form an angle theta when we go in the counterclockwise direction. However, when we go clockwise, we form a negative theta. And this raises a good question as to what happens when you have, say, cosine of negative theta. What does this equal? Well, the clue for that is going to be our graph here. So when we look at our graph, notice when we have positive or negative theta, our x-coordinate is the same. That means here since we share the same x-coordinate, that's going to tell us that this is going to just equal x, or a better way of putting it, in fact, is let's delete that and say that this is the same thing as cosine theta. Because if we think about cosine theta for a moment, well, cosine theta is giving us this x value. Well, cosine negative theta is going to give us this x value down here, but it's the exact same x value. If we can pretend, we could imagine a straight line going straight down here. So I guess just to note that this line right here would be straight. So because this line is straight down, that means the x-coordinate is the same, and so we can make this conclusion here. We can make a similar conclusion about sine. So sine of negative theta, notice it's the negative of the y-coordinate. So when we think about sine of theta, well, sine theta is equal to y, but when we have a negative inside that we're plugging in, so negative theta, we get negative y. That means we have a negative right here, negative of sine theta, because if you take a negative 1 multiplied to sine theta, you get negative y, and so that's this right here. So this gives us a way of dealing with negative angles being plugged into sine and cosine. And once we know sine and cosine, we can refer again to our reciprocal identities to figure out what happens with tangent, cotangent, secant, cosecant. So we'll do our work down here. So tangent of negative theta is the same thing as sine of negative theta over cosine of negative theta, which is the same thing as negative sine theta over cosine theta. And here it's negative 1 times this ratio of sine divided by cosine, so negative tangent theta. And the proof will be very similar for cotangent negative theta, so let's get these up here. Tangent negative theta is equal to negative tangent theta. And I guess we can put parentheses around these. Cotangent of negative theta will also equal negative cotangent theta. That's convenient. Now, when we think about cosecant, cosecant we said is 1 over sine theta. So cosecant theta is equal 1 over sine theta. So when we consider a negative angle being plugged into cosecant, it's going to be 1 over sine theta, so it's also going to be negative. So cosecant of negative theta, we should probably make that a little better. Cosecant negative theta is going to equal negative cosecant theta, and this is because of this fact here. If we plug a negative in here, the same thing as sine of negative theta. Which is this 1 over negative sine theta. And we can make a similar argument, but with secant and cosine, to show that secant of negative theta will equal cosine theta. Now, these properties here are called the even-odd properties. Let's zoom out a little bit more. There we go. So these are called the even-odd properties because functions are defined to be even if you plug a negative x into your function and you get out just whatever f of x is, and by definition a function is odd if you plug in a negative x into your function and you get out negative of f of x. Classic example of this is y equals x squared and y equals x cubed. Two examples there of even and odd. Alright. So we can conclude then cosine is even, secant is even. So we'll highlight those. This one and this one. Those are even and the rest are odd. Alright. With that, we are going to conclude this video. So, thank you for watching this episode of Math with Haas. If you have been enjoying our content, please subscribe. Consider supporting us on Patreon. Your support goes a lot towards supporting this channel, and we appreciate all your love and support. Thank you for joining the math party, and we'll see you next time.